Here we have a simple pendulum prac that's been set up. It's been set at 53 degrees, which we wouldn't do normally, because the rotation of the Earth has an effect on the pendulum, and it'll cause it to crash into the object that we're using to hold it up. In the lab we use retort stand string and mass carriers. Here we can change the length of the pendulum, we can change the mass of the pendulum. For this dot point, we don't really need to be changing mass or drop height and those sort of things. We are mainly focused on changing the length of the pendulum, and the reason for that is the length and gravity has the effect that we're after. Those are the variables that affect the time for a full period of this pendulum to swing, so out and back. So here we can measure, if we start it running, off it goes, and you can see at a certain point I'm going to start recording. Whoops, wrong button. And I'm recording the time at the top of the swing. And again, I didn't record each swing, because if I do that, I'm compounding my error at timing. So what I want to do is count 10 swings. So we're going to reset the experiment. Reset our timer and count 10 swings, and then divide the total by 10. That will give us the period for one swing out and back. We do that for accuracy's sake and validity. If I use every single swing and record the time, I'm getting an error in every single swing. If I record the time for 10 swings, I'm only getting that time when I start and stop the stopwatch, where I might make the error. So here we go, we're going to swing out, and I'll start when it gets to the top of its height. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 21.3, that's in milliseconds, seconds and minutes. This is for a mass of 0.05 or 50 grams or 0.05 kilograms, and our pendulum length is 1 meter. If we switch over to Excel, you can see I've got some data here that I've just put in. I can put another one in, and by repeating results we're increasing the reliability of the results, and it was 21.3, so we'll put that value in. Now I will take more than 2 results, say 5, 6, even up to 10, take the average. That would give me the pendulum oscillation for 10 swings at this mass at 0.05 grams. Here I can take this value and divide by 10. So if I'm using a spreadsheet, that's pretty easy. I want to equals this value divided by 10, enter, and you can see we're getting a time of around 2 seconds, a little bit out, and that could be my timing. So this is an inaccuracy, my reaction time at the top of that pendulum swing. Is it there? Is it there? You know, there's a bit of error there. So this is one of the errors that creeps into our experiment, the timing of this pendulum. There are some other errors. The string might be changing length as it swings. There are a whole variety of errors that can contribute to the final result that we're looking at. So if I switch over here, you can see that they're pretty much the same. In fact, if I did this 5 or 6 times, the period would be pretty much the same, around 2 seconds. And our length of pendulum in this case was 1 meter. The release height we kept constant, and the earth and spinning. So gravity we're going to work out using this equation down here. This is the pendulum equation. So we've got period equals 2 pi times the square root of the length of the pendulum divided by a value for acceleration due to gravity. So on Earth we think, and we know, it's 9.80 meters per second squared, But we know about variance because of other things, other contributing factors. So we're going to have a look at that shortly. So now we're going to change the length of our pendulum, keeping mass consistent and our drop height consistent. So we want the only variable to be changing is length, and we might put it down to 0.5 of a meter and set this up so we've got the same angle of release, and then we're going to do the same experiment. We could be changing mass, but then if we change two variables we won't know which one has affected the result, the time the pendulum is swinging. So that would be an invalid experiment. So here we go. Start the pendulum swinging, and I'm going to try and time that from the top. And I'll just reset that again because didn't quite get that, and reset our experiment. And it's resetting back to the saved version. Okay, so that's our pendulum. Okay, we're ready. Go, and I want to start recording at the very top of that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 15.10 for our time. We switch back to Excel using the same mass, but using a different length this time. So here we might have length of our pendulum 0.5, and our new time was 15.10. And that's the time for 10 swings, 10 full oscillations out and back. And we put a formula in here. You can see here, this cell divided by 10, and we've done the same here. So that's just moving the decimal place. We might actually move our length column and put length here instead of mass, because mass is not something that we're keeping the same. Okay, so we had a length of 1, here we've got a length of 0.5. And I'm just going to do some readings now to continue that for a variety of different lengths, and we're going to then graph this result. So here you can see pendulum working with 0.3 and still the same mass, and we're getting a much faster swing. If we look at our results so far, if we switch over, and we can see here we are getting an effect, so it is having an effect on the length of the pendulum. And now we can use this formula to work out what our result will be. So here we've collected a group of different values for different lengths of our pendulum, and we've got the time for 10 periods of oscillation, and then the time for 1 period of oscillation at those various lengths. You can see it's changing. However, because both are changing, we know that this is the only variable we're changing. This is a variable we're measuring, so independent variable, dependent variable, and here's our results. We squared it because in order to rearrange this formula, we have G equals 4 pi squared on L divided by the period squared, and that's just from rearranging this formula. And you can see there's t-squared values, and then we substitute those in. So here we've got a group of different values calculated for gravity using this formula. This formula, by the way, is not given in the HSC, so you'll have to remember the top one. and then rearrange it if that's what you're required to do. Probably I'm hoping it would be given to you. So we might take the average of this column, and we'll just, so we want to work out the average for this column, and we're going to use a formula in this case in Excel, but we're going to add these values that we've worked out for G at different pendulum lengths. And remember, each one of these we've tried to minimize as many errors as possible. We took 10 swings, divide by 10 to get 1 swing period. We've then squared that. We were very careful with our timing. The same person used the timer each time. There are some experimental errors, so my release time, my reaction time was not as constant as it could have been, but that's the reason we use the same person to do it each time. So here's our mean, so we want to put average value, and we could have taken many more lengths, and don't forget we've taken multiple tests for each of these pendulum lengths. So this one here is the mean that we've used. So our average of these 4 values, and close bracket, enter. And you can see there our value for gravity is 9.432. It should be closer to 9.78 or 9.8 in this location. So you can see there is some variance, and those values have variances from a variety of things. It could be the length of the string stretched. It could be my reaction time was slower on some timing. It could be built-in error. The ruler for the spring, we used millimeter ruler, so down to thousandths of a meter accuracy, and that's actually half the limit of reading, so half a millimeter accuracy. So yeah, there's our value for G. A good experiment to test errors and things like that. For risk assessment, we would probably just be careful that we don't hit with a swinging pendulum or knocked off a desk or something like that. We used a weight to hold the pendulum on the desk, and yeah, 9.432, fair way off, so we'll need to do some more work to get that right.